would like you to keep the questions, mostly the comparative questions, to the end. So how does this relate to Flutter or Kyle or all these technologies you might know? So leave these things to the end so the time can goes on and we finish the talk. Okay, so it's time. Let's start. My name is Gustavo. I work at Instituto Norte de Tecnologia, that is the INdT. The translation is Nokia Institute of Technology. It's related to Nokia, but it's an independent institution. It's a non-profit institution. So we try to do good research that maybe Nokia will use later. So this doesn't reflect any of Nokia opinion. It's INdT only. I'll talk about my background. I just graduated 1.5 years ago, so I'm quite new, but while doing my undergraduate, I was working with Pygame and SDL with the Freevo project. So, do you know BitTV? Maybe you know Freevo. They are similar projects related to PVR. So, I did the current UI of Freevo. I wrote the TV guide, I wrote the folders, visual folders. Most of the UI was done by myself by 2002. And then I deal with compilers and low-level stuff. I worked for LTC, IBM, Brazil. And since I graduated, I worked for INdT. At the beginning, more as a general programmer, but now I'm leading the development of these technologies that will be the foundation of our next products. So here, who knows about the Enlightenment project? It was quite famous before. Okay, many think it is dead. I thought before this year because I met Enlightenment by '99 and it was really fancy, but I didn't have a machine that supported all that fancy stuff by that time. But doing the research to see the alternatives for the UI for our next product, I've met the core developer, Austria, and some of the other guys, and the project is still going. It was a bit slowly, going a bit slowly before, but now it's in full motion because INdT has at least 4 developers working on it. OpenMoko now hired the core developer, and we might get some more speed in development. So let's go on. So after all these products hit the streets, the consumer expectations got a bit higher. Like you see the size of the iRiver, you see this PSP, you can get a really interesting interface with these products. And last, the iPhone was like a boom. Everybody that touched that device wants something similar in their possession. So even if you don't like the iPhone, even if you don't like the Apple, I don't have anything from Apple. Actually, I have an iPod, but I don't like it that much. But if you have used the iPhone, you might be interested that they pay attention to the detail. And instead of making you wait with a frozen screen, they do a little nice animation that doesn't get in the way, and you are not bored anymore. Like when you take a picture, while the camera is still being ready, it's a camera stuff, not a CPU stuff. So let's do something with the CPU to not bother make the user board. So they do a little animation that you don't. It seems that the camera opens quicker. So that's what users expect nowadays. So here it is. What consumers expect these days? They expect quick feedback. You are not allowed anymore to click a button and wait like 5 seconds without some kind of response. Even a beep you need, or some kind of animation. And talking about animation, they expect like natural animations in the sense that match the real world. So when you throw something out, it goes out. If it hits a wall or it has an elastic cable, it goes back. So users expect this kind of features in their device. One of the reasons is that it clarifies the workflow. So instead of making a tooltip or something else to make users understand why it's in that step of the workflow, just give the visual hint that users came from one stage to the another. So just don't replace one screen with the other, that users take some time to understand what happened and if it happened something at all. It also happens users identify when the device is frozen or not. So when you have a device and you click to open an image, it might be a huge image. So it might take like 2 or 3 seconds just to load the image from disk. So if you take this time to load the image from disk, users will think that the device broke and throw it away. So what you should do, you should try to compensate this wait with something that just distracts the user without being cumbersome. So this is the last part, and of course they want it to be beautiful. So if you build with graphical artists, we have like 5 artists at INdT, you will know that they are all of effects in mind, but it's hard to match these effects with some of the existing technologies like GTK and a few others, even Qt. So let's talk about the technologies we use today. So ELCE-2007, for those that doesn't know what it really is, it's an input-output method. Okay, it handles the input devices, handles the events to you in the form of keyboard events, mouse events, and even expose events. When one window covers the other, it requests the bottom window to draw itself. Okay, it doesn't keep the state so far. You can use the double buffer extensions or something else, but the basic work is just to forward events and do the output that is getting the image from one side and drawing to the frame buffer. It's a networked protocol. That what makes it interesting, because okay, you can run it through a network, but it also provides a good isolation of the drawing primitives, the drawing core, and the applications. Like if you draw directly to the frame buffer, you might get a bit of speed, but it doesn't work with the trouble. So it's better to have something synchronizing what are being done, what are being executed, what is being incoming, what's incoming and outcome. This network protocol is quite optimized for the use it has. So it's not like a general purpose protocol only. It has like the most common events have the smallest size, and you have like Unix sockets to avoid doing TCP. You don't have to have an overhead just because you have a protocol to handle this interface. So it's quite efficient, it's quite fast. If you have shared memory on your system, probably you use shared fixed maps, and avoid copies at all, so it's quite optimized. It's not a bad thing as was touted in 4 or 3 years ago. It's used in many Unix systems, not just Linux or BSD. Many Unix systems has it, including the Apple, as an extension for their system. It provides just very basic primitives. In the means, it doesn't know how to draw alpha blending by default. You have to have an extension to do that. It just draws lines, rectangles, and handle rectangles in general. It's very difficult to get right if you are not experienced text programmer, because you have to deal with the events map. It's all synchronous, so it's a bit of pain to deal. For example, if you want to build a button, in general you will have to create a window, map this window to the parent window, set some flags because you want them to receive the events, and it's a bit of pain. So usually use toolkits on top of that. The most famous are Qt from Totec and GPK from the GIMP. But we also have SDL. It's not actually a toolkit, but it's an abstraction. EVAS, that's what I will talk about. TK, XOL, and TIFF, and other layers. So, what is the OpenGL that everybody wants to talk about and say it's the future? OpenGL is an industry standard for access the 3D hardware on the systems. It's not the magical solution. It doesn't do fancy things for you. It just provides the means to you to draw the fancy things yourself. So it's not the heaven solution. 2D, that is what we use on our desktops, is just handled as a case where every image has the same plane, so it's a subcase. It's not really optimized for that. It's handled as a subcase. It's not that used just for desktops nowadays. So what it does well is the triangle, rectangle, and maybe polygon blitz fast. It does it fast. But what happens when you try to blitz some font on the screen? It doesn't handle fonts in most versions. What you need to do is tessellate this font. So you need to get these complex curves and break it in small rectangles. That is a bit of work. So if you don't want to do the pixel painting on the CPU, you will have to do this tessellation job that is really hard. It's a lot of math, and it's also you also pay the price. So if you just use it once, it's a bit of overhead. What it also does great, especially in the last versions, are the transformations. Like you can have pixel shaders, vertex shaders, and even program the CPU as a general purpose processor. So you can do almost what you want, but you have to map to matrix operations. So convolution, multiplication, dot product, all those stuff, it does very well. It also handles fast alpha blending. You just give it the alpha blending, also handles scale very well because scale is a matrix transformation. And as I said, the high-end cards also support pixel shaders. That is a small kernel program that you put to be executed by every pixel on the screen on that given area. So GTK, most of you are familiar with it because of the Ubuntu. Many I saw using it, so at least you know it visually. GTK was built by the GIMP people to to build their image painting program, Photoshop-like painting program. And they found lots of problems drawing directly to X, so they abstracted using the GTK and GDK. GDK is the drawing primitive, GTK is the toolkit. On top of it, its focus is on visual widgets. So you have buttons, you have forms, you have layout systems, you have 3-view, text view, lots of components. But the focus is on rigid form applications. Like if you want to do a store control system using GTK with all labels being equal and aligned to the same side and those things, it's very, very good. But if I call it later, some efforts to run on non-X. It runs on Windows, it runs on DirectFB, it runs on another system, but the main focus is X. It's tied to X in many ways. Like I said, if you want to create a button, the canonical way is to create another window, fix this, attach this window to the parent, and this window that represents the button will be handled by X. So this brings some problems in the simulator, mainly due to the transparency effects that X doesn't support without an extension called Composite. It just provides free, basic free drawing operations, so you can handle any fancy vector graphics with it. You need Cairo, that is a complex 2D vector drawing, and not GTK at all, because GTK you just paint images and draw basically primitives in immediate mode. I talk about it. It was adopted by my own project because at that time, 97, something like that, the KDE project was based on Qt. Qt was a weird license, and they wanted an alternative, and Free Software Foundation was also pushing for an alternative, and then the GNOME project was born and using this software. And it has no OpenGL support because it doesn't make sense for the purpose it was conceived. So SDL, the first version of our software was entirely based on SDL because some of the developers already know it, and it provides so few primitives that the learning curve is very, very short. So it's easy to understand because it just provides a memory buffer. So if you know how to paint memory buffer, you are done. You just have to do it. But it doesn't provide any fancy operations like lines, rectangles is a some case. It does, but not anything that fancy. It doesn't provide any layout stuff or nothing like that. No toolkit, no nothing. So it was born as an abstraction layer to port Windows games to Linux by Locky Games. And it fit that purpose very well. It's used by many games. Provide OpenGL support because, but this OpenGL support is not something advanced. It just exports some way to create the OpenGL buffer, and that's it. You might use the GL utilities to draw the primitives yourself. So you are almost alone in the dark. The main problem, for us at least, is that the developer needs to care about everything themselves. I will talk about the scene rendering later, and you will see that doing a complex scene manually is boring, it's error-prone, so it should be avoided. And if you try to do something fancy on top of that, you will end with EVAs or GTK or something else. So it's pointless to develop this kind of application with just SDL. A game is probably fine because you need an engine and game is based on SDL, so it's not my first time using it, and the second time I reached the same conclusion that it doesn't scale to this development model. So what is a scene rendering manager? What it does? So when you have to paint a screen, a window, I always exchange window and screen. It's the same thing, okay? When you have to paint a screen, being a GTK application, a KDE application, or a game, you have to manage what you have on the screen, what changed, and try to minimize what you have to repaint. So if you want to be efficient, you have to paint as less as possible. And to do that efficiently, it's real pain. So, as it's written here, I will not repeat to not be what you have to do is basically remember states and make a GIF of both states and take an action based on that GIF. So if things have to be drawn, draw. If things have to be erased, erase. So that's the job of the manager, composite manager or screen manager. So the screen manager role on each platform I'm saying here is X11, SDL, and GTK. It's up to the developer. GTK, it's a bit different because GTK itself, if you want to use like a button, then it's a software job. But here we are focusing on fancy applications. And if you have to do that, you need to go down to the GDK level. There's the drawing primitives, and you are quite lost. You don't get anything for free. You have the immediate rendering mode, so everything you draw is draw once and lost. No states to remember it for you. This changes with EVAs. So EVAs is the canvas. Okay, I will talk more about it later. It was meant for it. The developer that wrote it was previously a GNOME hacker, also a GTK contributor, and he saw some drawbacks on that model, and he wanted something different. So often the layers that he chooses are a bit different from the ones that you see in hardware software like GTK. So here is the example of two renders, one with EVAs and one with another. So, sorry, I don't have the display working here, so it's a pain having reflection of this slide there. So, actually, this is what the manager has to do to move a ball. So, it has to calculate the position, see if it changed. If it changed, clear redraw. If you need to redraw, you need to paint ball 1, paint ball 2, and clear with the background. We call that erase. It's actually a new draw, but you have to erase. What's the problem here? If you have to do it by hand, it's possible, sure. It's the same thing, you just have to apply the same algorithm. But it's lots of stuff that you have to keep in mind while developing it. So you have to try to remove overlapping areas. So if you have the background, it's usually opaque, so it's not transparent. And you have another icon over it that is also non-transparent. You shouldn't draw the background, even if it's dirty, because the image on top of it will be the draw again. So you need to minimize the areas you want to redraw. And in the process of optimizing these areas, you should also not have too many small areas, because you have to communicate to X. And next, we will use usually memory copy, mem-copy, and to do this operation. And it's often not optimized for small copies. And if you need to exchange lots of errors with X, you have to do lots of calls or one call with lots of rectangles to be redrawn. So you really have to balance, minimize the errors, but maybe allow some errors to be redrawn more than once or redraw a bit more than it's required in order to optimize, in order to try to align memory, so it's really a pain. So this one is the ELCE approach. ELCE is a stateful canvas, so it reveals the state for you. It does all this calculation for you. Okay? You just have to create and move the balls. Everything where the ball was is handled by you. If the ball was visible or invisible, if the ball was colored with red and then it's colored with green, all this is handled by you in an optimized way. Also, we have the theme ability of the engines. On the left, you can see the basic theme ability. That is just, okay, let's replace some pix maps, let's replace the font, let's replace the thickness of the line, and that's all. On the right, what I call advanced theming. That is, you can even change the layout, you can change the form, you can change the position, you can change almost everything. On the left is the one supported by things like GTK, and on the right is the one supported by a layer on top of ELCE. It's called Edge. So X11 and SDL provides no time support. It's not the scope of the both projects, so it's pointless to have. GTK is just basic themes. You have to write something that draws on the same factor, form factor. Just replace the bits map in general. If you want to do something different, you have to override some methods. So I don't consider that theming. I consider that overloading the component. Okay, and Edge is CSS-like scripting language, CSS-like interface specification language that also has scripting. So I call it theme scripting language. Something like a mix of HTML, JavaScript and CSS. So here, why not the technologies I said here? SDL is too much pain for the developers. So if you cannot scale, if you have like two components, pluggable components on the same screen, it's impossible to do with pure SDL. You have to create another layer on top of it to manage these pluggable objects, and then you have or GTK or ELCE, so it's pointless to keep doing that. So why not GTK? GTK is too rigid. If you have to do some kinetic listing or some fancy animations where one item covers the other in a semi-transparent way, it's almost impossible nowadays. You have to do so many hacks, apply patches, rely on X extensions like composite. So it's really difficult to get beautiful. That's the problem. At INdT we also have many GTK programs and applications because we work with Nokia, and Nokia solution so far is to use GTK, and we have beautiful applications with GTK, but believe me, it's a real pain. Okay. EVAS has this stack, this official stack on top of it that is called Edge. Edge is this team support. You can do like small programs, transitions, and everything you want in this team. I will show some demos and say what is done by EVAS directly, what is done by Edge, and what is done in C or Python. You also have the ETK or EWL widget support. So ETK is based on almost a copy of GTK. It's based but more on GTK1, but still if you know GTK you can fast start code with ETK. It's the same concepts, almost the same calls. And ETK has also a layer called Enhance. Enhance provides glade loading support, so you can get your glade from GTK and load it with ETK. So it's a really well optimized core engine. I have worked with this 16-bit per pixel support, and it's really fast on the device. I use lots of tricks to make it fast and look as good as possible, because you are using precision, so you may get ugly graphics if you do it in another way. And I also took care of optimizing this rectangle splitting and merging to handle the overlapping errors. It was a bit tricky to get right. I asked some people like Carl Worth from Cairo, famous teachers on the internet, and people from graphics that I know. The algorithm is really well handled because it handles very corner cases with a good heuristics. So the algorithm is quadratic, but we can handle it in here to n log n, so it's quite fast based on the number of operators. It has excellent X11 support, so it uses it very well, but it just uses one X window per widget if you want to do something using ETK, because it handles all the components internally like objects on the same surface, so you don't need like 2 or 3, you don't need more than one window per EVAS canvas. It also has a small footprint because we are talking about embedded systems, so we don't want like 12 megabytes. It's really small, it's focused on efficiency, and it also has a good separation of the layers. So EVAS, I will talk about it later, but EVAS is the canvas, Edge is the theme. You don't need the theme if you're not using it, so you can rip it off. You don't want to use ETK, fine, just don't compile it. There is eCore, there is the main loop and event abstraction layer. If you don't want it, don't use it. You can use like a GUI main loop or do your own. So it has very few external dependencies. Most of them are customizable, except by FreeType and small other libraries. It's ESB licensed, so if you are doing some weird closed source software, just use it, and you don't need to give the code back, but we really wish if you contribute back. So it's more a trust than enforcement. Okay? And designers will depend less on developers, because I will show you later. Designers can do things on Photoshop, and we have a filter to just generate edge. They can test and see if the pixels match the position they want, and even do the small animations. It all makes the fancy applications easy to write. So without EVAS, the workflow was first the artist designs something, then they show it to us, then we explain how to cut the images. If you are using like SDL, you have to cut every part of the images. You don't have advanced primitives. Like if you want to draw a button that is a scalable button, you have to split the button in corners. So you have 4 corners. You have the top and the bottom border, the left and the right, and the center. You have to have all these images separated. If you want to scale the button, you have to, okay, I need to scale this one, that one, not the others. Just scale, apply the scale algorithm. EVAs handle that for you. Edge also provides means to control this behavior. So it's really easy to have the artist to cooperate. So then we had to compile, install, and test how it works, if it works or not. With Edge, we can use like Edge Viewer, and with Edge Viewer, you can just fire the demo, and you can even send some signals, and this will trigger the transitions and animations that you want. So they don't need us anymore. And it's a bit like web development. So they, at least our designers are previous web designers, so they know how to open a web browser, do some minor programming. Our web designers know a bit about JavaScript, so they can write something, they can test something without the need of a real developer that is costly. So here is the almost official EFL stack. So we have eCore, first EVAs, that is the drawing canvas. It doesn't know how to handle X expose events, or frame buffer expose events, or frame buffer input output. It doesn't know that. Okay? It just knows how to draw things. It has a notion of how to draw to some surfaces, but it doesn't handle the surfaces incoming and the problems itself. That's it's a job of eCore EVAs. First eCore handles the events and main loop and timers, idlers, everything that we want to have a event-oriented application. With eCore EVAs, eCore is subdivided in lots of modules. One of them is eCore EVAs that does the group. It groups the events from X or the input from frame buffer and forwards to EVAs and get the results and reads. So everything is handled by eCore EVAs, but if you want to do your own input output, you are free to do that. Edge is the team, like I said before, and ETK, WL are the widgets on top of that. These widget sets are much more simple than GTK or Qt, because most of the hard part is done by other libraries. So you don't have to do much work. You just have to calculate the positions, choose the right component from Edge, and that's it. Handle the events. That's not much to do. So here I will start a technology showroom, lots of demo. So if you want to ask something before, I can show the demos after. If you don't, I can just start the demos. Okay, I will start showing you the Rage. Rage was a DVD player that started in a weekend by Austria. The name has a purpose. He was pissed off with Japanese DVD players. He is not Japanese, so he was not used to the Japanese language and wanted to play region-free DVDs. So he started with this Rage on weekend using Zine, And later we have also GStreamer support. So I'll show you. So this is the page start. It's scanning for media. We also have a media scanner, a very fast JPEG thumbnailer. So most of this doesn't work, right? Like if you see music, it's 0. So let's see what works. The computer is a bit slow now, but the software feels great if you have something. Yeah. And it's also running on X, and my X is a bit slow after some patches I applied to get to. So what we have here on the left side is the thumbnail preview of the movie, and on the right side is the live movie being decoded, played with conversions and overlay on top of it. So it's real time, and it's being converted from Zine, but you can also use FFmpeg, and it outputs to this. It converts to RGB to do the overlays on top, and then show it's quite fast. Not on my machine, but on a new PC, it can handle like full HD videos really fast if you use the OpenGL support. So I quit the application, and what's the others? So this was great. The facts about it, it was written in a weekend, as I said, and it's less than 7,000 lines of C code. If you use Python, it's even less than that. And about 1,000 lines of scripting, but you will see that the script is very verbose, so you have to type a lot, but if you use Emacs, I can send you my .Emacs, and I have lots of macros to hide the development. There are some for VI also. And if you want to do these things, we also have this GIMP plugin to get from any format that GIMP handles and output. So this is the environment nowadays with a small factor. I will not show you now. Editor, this is Expedit. Almost on time.
Yeah, so do this demo quickly.
Okay.
I think
So
Expedit
Expedit
the
is
next presentation after.
okay. Expedit is the benchmark tool. You can see like these operations. This specific test is about 50 frames per second on this device. Is about 3 on my N800 device that is like 200 megahertz, 300 megahertz, and no acceleration at all. So this is much faster on the device. Is about 13 frames per second using the 16 bits engine. You have more engine and more tests. So this is the test that Carl is using to benchmark Xhander nowadays, because it supports Xhander, Xhander XCB, Xhander XLib, OpenGL, software. So software, incredibly, software is much faster than Xhander that is supposed to have higher acceleration. So software is really fast. So I have other quick demos here. Here is an application launcher demo. Done in Python is just the launcher. Everything is script expulsing. This come to center is just edge. also have this virtual keyboard.
I'm afraid I really have to stop you. I'm quite sure that you can continue for ages. And it's actually quite nice to look at.